Data structure questions are an important part of any programming job interview. Sound knowledge of data structures and algorithms will help you stand out from the crowd. Hence, we bring you this session on data structure interview questions. Let's quickly look at the agenda. In this session, we shall understand the need to learn data structures. Following that, we shall discuss data structure interview questions, which will include few generic questions, questions based on different data structures, and also based on algorithms. In the end, we shall understand the most commonly asked math puzzle that makes use of data structure concepts. Let's quickly look at the agenda. In this session, we shall understand the need to learn data structures. Following that, we shall discuss data structure interview questions, which will include few generic questions, questions based on different data structures, and also based on the algorithms. In the end, we shall understand the most commonly asked math puzzle that makes use of data structure concepts. So let's start with understanding why do we need data structures. A lot of you must be wondering, why should I study something complicated like data structure if it has absolutely no use in real life? Why do companies even ask questions related to data structures and algorithms? A lot of beginners and experienced programmers avoid learning data structures and algorithms because it's complicated. So before we discuss the interview questions, we are going to look at a simple problem here. Suppose your exam results are out and the college provided the results in a PDF of 8,000 pages with students' results arranged as per their seat number. Now, even if it is arranged, imagine how long it will take for you to just randomly find your seat number from 8,000 pages. Now, imagine you come up with a strategy. Let's start with the center page of those 8,000 pages. So go to page number 4,000. If your seat number is not there but all the other seat numbers in the page are greater than yours, then you just eliminate the pages after 4,000. Now go to page 2,000, which is between 0 to 4,000. Still, if your seat number is not there, but this time all the other seat numbers are lesser than yours, you can again find the center and go to page number 3,000. Continue the same process till you find your seat number. But guess what? You just have used the binary search algorithm. Now imagine a computer doing this for you in the same way in a matter of few seconds. Wouldn't that save your time and efforts? Now this is just a very simple and small example. But big companies like Facebook, Google, Netflix, or even startups like Airbnb, DoorDash, and Bloomscape make use of data structures in their day-to-day work. Hence, if you want to bag a technical job like maybe a programmer in pretty much any company, you need to have substantial knowledge of data structures. So stay tuned as we are now starting with the most commonly asked interview questions on data structures. The first question is, what is data structure? Data structure is a way to specify how to organize and manipulate the data. It also defines the relationship between different sets of data. When dealing with data structure, we not only focus on a single piece of data, but rather on different sets of data and how they can relate to one another in an organized manner. Data structure is not any programming language like C, C++, or Java. It is a set of algorithms that can be used in any programming language to structure the data in the memory. Some examples of data structures are array, linked list, stack, and queue. The next question is, explain the types of data structures. Let's start with primitive data structures. These are the data structures which are supported at the machine level. They can be used to make non-primitive data structures. These are integral and are pure in form. They have predefined behavior and specifications. For example, integer, float, character, and pointers. The pointers, however, don't hold a data value. Instead, they hold memory addresses of the data values. These are also called the reference data types. Then let's talk about non-primitive data structures. The non-primitive data structures cannot be performed without the primitive data structures. Although they too are provided by the system itself, yet they are derived data structures and cannot be performed without using the primitive data structures. The non-primitive data structures are further divided into linear and non-linear data structures. A data structure is called linear if all of its elements are arranged in sequential order. In linear data structures, the elements are stored in a non-hierarchical way where each item has successor and predecessor, except for the first and last element. For example, array, linked list, stack, and queue. The non-linear data structure does not form a sequence. That is, each item or element is connected with two or more other items in a non-linear arrangement. The data elements are not arranged in the sequential structure. For example, graph and trees. Moving ahead to the next question, what are the advantages of data structure? The major advantages include efficiency, reusability, and abstraction. Let's understand how efficiency is an advantage. If the choice of data structure for implementing a particular abstract data type is proper, it makes the program very efficient in terms of time and space. Data structure helps in efficient storage of data in the storage device. Its usage provides convenience while retrieving the data from storage devices. Data structure provides efficient and effective processing of small as well as large amount of data. The next advantage that we are going to talk about is reusability. The data structures provide reusability means that multiple client programs can use the data structure. Significant performance improvements can be achieved by reusing the data structures and computing the same data values that are always the same, rather than reconstructing them. The third advantage is abstraction. Data structures specified by an abstract data type also provides the level of abstraction. The client cannot see the internal working of the data structure, so you don't have to worry about the implementation part. The client can only see the interface. The reason we use abstract structures is because they effectively use memory based on the design of the data stored in them. With very large amount of data or very frequently changing data, the data structure can make a huge difference in efficiency of your computer program. The next question is list the operations you can perform on data structures. The operations include traversal, searching, insertion, deletion, and sorting. Traversal is used to access each data item exactly once so that it can be processed. Searching means finding a particular element in the given data structure. It is considered as successful when the required element is found. Searching is the operation which we can perform on data structures like array, linked list, tree, or graph. Now, insertion is the operation which we apply on all data structures. Insertion means to add an element in the given data structure. The operation of insertion is successful when the required element is added to the required data structure. It is unsuccessful in some cases when the size of the data structure is full and when there is no space in the data structure to add any additional element. Insertion has the same name in data structures like an array, linked list, graph, or tree. In stack, this operation is called push, while in queue, this operation is called enqueue. Next, deletion is the operation which we apply on all the data structures. Deletion means to delete an element in the given data structure. The operation of deletion is successful when the required element is deleted from the data structure. The deletion has the same name as deletion in data structure as an array, linked list, graph, or tree. In stack, the operation is called pop, while in queue, this operation is called dequeue. The last operation is sorting. Sorting is arranging the data items in some order, that is, in ascending or descending order in case of numeric data, and in dictionary order in case of alphanumeric data. The next question is differentiate between null and void. Null is a value, whereas void is a data type identifier. Null indicates an empty value for a variable, whereas void indicates pointers that have no initial size. Null means it never existed, while void means it existed but is not in effect. Moving ahead to the next question. How does signed and unsigned numbers affect memory? In case of signed numbers, the first bit is used to indicate whether the number is positive or negative, which leaves you one bit short. It takes up one bit of memory that could otherwise be used to represent a value. With unsigned numbers, you have all the bits available for that number. The effect is best seen in the number range. An unsigned 8-bit number has a range of 0 to 255, while 8-bit signed number has a range of -128 to +127. The next question is differentiate between static and dynamic memory allocation. Let's first understand static memory allocation. Static memory is allocated for declared variables by the compiler. The address can be found using address of operator and can be assigned to a pointer. The memory is allocated during compile time, while dynamic memory allocation is done at the time of execution, that is, at runtime. Hence, it is known as dynamic memory allocation. Functions like 𝐶alloc and malloc support allocating dynamic memory. In dynamic memory allocation, memory space is allocated by using these functions when the value is returned by functions and assigned to the pointer variables. The next question we have here is explain the role of malloc, 𝐶alloc, realloc, and free function in dynamic memory allocation. So malloc is one of the functions used for dynamic memory allocation. It takes up single arguments, which denotes the number of bytes to be allocated. Malloc is faster than 𝐶alloc. 𝐶alloc is one of the functions used for contiguous dynamic memory allocation. It takes up two arguments, in which first argument denotes the number of bytes to be allocated and second argument denotes the size of each block. It initializes allocated memory by 0. The realloc function is used to resize the allocated memory without losing old data. If the dynamically allocated memory is insufficient or more than required, you can change the size of previously allocated memory using the realloc function. The last function we have here is free. It is used to free the memory block that has been allocated dynamically. Memory created by either 𝐶alloc or malloc does not get free on its own. You must explicitly use free to release the space. Moving ahead to the next question, differentiate between storage and file structure. The major difference between both the data structure is the memory area that is being accessed. In storage structure, the memory that is allocated to a variable or a constant is stored in the main memory of the computer, that is the RAM, which gets deleted as soon as the function ends. This representation of allocating the memory is called storage structure. In file structure, if you write the data in a file and save that file in a hard disk or any other external device like pen drive, then the data will remain intact till it is deleted manually by the user. This representation of saving the file in an auxiliary or secondary memory is called file structure. The next question is explain recursion. The ability to allow a function or module to call itself is called recursion. Either a function f calls itself directly or calls another function g that in turn calls the function f. All the recursive algorithms must have the following. The first one is the base case, that is when to stop, then the work towards base case, and lastly recursive call. The work towards base case is where we make the problem simpler, that is dividing the list into two parts, each smaller than the original. The recursive call is where we use the same algorithm to solve a simpler version of the problem. The base case is the solution to the simplest possible problem. The next question is differentiate between iteration and recursion. Recursion achieves repetition through repeated function calls, while iteration explicitly uses repeated structure. Recursion terminates when base case is recognized, while iteration terminates when loop condition fails. Recursion returns a value to the calling function, while iteration does not return any value. Moreover, recursion makes a code smaller, while iteration makes a code much larger. Hence, recursion is a slower process than iteration. The next question we have here is, do all declaration statements result in a fixed memory reservation? So the answer is, except for pointers, all declaration statements result in fixed memory reservation. Instead of allocating memory for storing data, a pointer declaration results in allocating memory for storing the address of the pointer variables. So the last question in the generic section is, what are infix, prefix, and postfix notation? In infix notation, the operators are written between the operands. This is the standard way of writing expressions. Next is prefix notation. It is also called as Polish notation. Here operators are written before the operands. The last one is postfix notation. It is also known as reverse Polish. Here operators are written after the operands. Now moving ahead to the questions based on array. So the first question here is, what is an array? An array is a data structure that contains a group of elements. Typically, these elements are all of the same data types, such as integer or string. Moreover, an array can also hold primitive types and object references. Arrays are commonly used in computer programs to organize data so that a related set of values can be easily sorted or searched. One thing to note about arrays is that the length of an array is established when the array is created. After the creation, its length is fixed. So the next question is, how to create an array. An array is declared similar to how a variable is declared, but you need to add square brackets after the type. You can use the brackets after the array name or even after the data type of the array. You can see in the example as shown in the declaration block here. Let's understand this better with the help of a code. So you can see here the code. Initially we have declared an array over here and we have allocated the memory for the array in this section. We are allocating memory of 5 integers over here. Now what we are doing is we are initializing the elements. So here is the first element, which is the 0th index of the array, and so on. Later we have used the for loop over here for accessing the elements of the specified array. Now as you can see here, we have used brackets after the array name. Let's run the code and see how it works. So you can see the code has worked and it shows the elements on each of the indexes. Now suppose we remove the brackets and put the brackets after the data type. Now let's run the code. And the code has executed successfully again. So you can see both types of declarations work. Now let's go ahead and see the next question. So the question is, can we change the size of an array at runtime? The answer is no, we cannot change the array size. Though there are similar data types available which allow change in size, but you cannot change the size of your array at runtime. An alternative is to create a new array which is larger than the existing one. Copy the elements of the existing array to the new array and delete the existing array. Moving ahead to the next question, what is a multi-dimensional array? A multi-dimensional array is an array that has more than one dimension. It is an array of arrays, an array that has multiple levels. The simplest multi-dimensional array is the 2D or 3D array. Multi-dimensional arrays make use of multiple indexes to store data. It is useful when we want to store a data that cannot be represented using single-dimensional indexing, such as data representation in a board game or tables with data stored in more than one column. Moving on to the next question. What do you understand by hashing? The technique of converting a range of key values into a range of indexes of an array is known as hashing. It is possible to create associative data storage using hash tables where data indices can be found by providing the corresponding key values. Now let's look at the questions based on linked list. So what is a linked list? A linked list is a linear data structure like arrays where each element is a separate object. Each element, that is the node of a list, is composed of two items, the data and a reference to the next node. A linked list is a sequence of data structures which are connected together via links. Linked list is a sequence of links which contains items. Each link contains connection to the next link. Linked list is the second most used data structure after array. So the next question is explain the types of linked list. So first we have singly linked list. In this type of linked list, each node stores the address or reference of the next node in the list, and the last node has the next address or reference as null. Next we have doubly linked list. Here we have two references associated with each node. One of the reference points to the next node and one to the previous node. The third one is circular linked list. Circular linked list is a linked list where all the nodes are connected to form a circle. There is no null at the end. A circular linked list can be singly circular linked list or a doubly circular linked list. So the next question is, are linked lists considered linear or non-linear data structures? Now this question can be a little tricky. So the answer is linked lists are considered both linear and non-linear data structures depending upon the applications they are used for. When used for accessing strategies, it is considered as linear data structure. When used for data storage, it is considered as non-linear data structure. Moving ahead to the next question, what is the difference between array and linked list? So the size of the arrays are fixed, while linked lists are dynamic in size. Inserting and deleting new element in an array is expensive, whereas insertion and deletion can be easily done in linked list. Apart from that, random access is not allowed in linked list, unlike array. Also, memory wastage can be seen in arrays if the array is not full, which is not the case in linked list as memory allocation is dynamic. The last difference is arrays have a better cache locality. That makes a pretty big difference in performance. So the next question is, what are the applications of doubly linked list? So doubly linked list is used by browsers to implement backward and forward navigation of visiting web pages, that is, the back and forward button. The next application is in image viewer where previous and next images are linked and hence can be accessed by next and previous button. After that, we have its application in music player. Songs in music player are linked to previous and next song. You can play songs either from starting or ending of the list. The fourth application is a deck of cards game. It is a classic example of application of doubly linked list. It is also used to store the state of the game during the play. Moving further with the next question, how do you search for a target key in a linked list? To find the target key in the linked list, you have to apply sequential search. Each node is traversed and compared with the target key, and if it is different, then it follows the link to the next node. This traversal continues until the target key is found or if the last node is reached. Let's understand this better with a code. So here we have an iterative Java program to search for an element in the linked list. So initially we have created this node class over here. Then later in this class, what we are doing is first we are creating a head over here, which is the head of the list. Then we have this function. What it does is it inserts a new node at the front of the list. This line here, it allocates new node and puts in the data that we have here in new data. Now what this line does is it makes next of the new node as head. And then here we move the head and point it to the new node. After that we have this function. It checks whether the value that we are searching we have here, which is in X, it checks whether this X is present in the linked list or not. Now in this function here we have initialized the current, and here we are checking if that data which we are searching for is present and current or not. If the data is not found, it will return false. Then we have our main function over here, which tests the above functionality. So we are initially starting with an empty list over here, and then we are adding elements to the list using the push function. So we have added 1, 2, 3, 4 and 5 in our list, and then using if else we are checking if the element we are searching for is present in the list or not. So here we are searching for 4, and if 4 is found in the list, it will return yes, else it will return no. So since 4 is there, we have added it in the list, so it should return yes. I will execute it again and let's see if it returns yes. Yeah, so you can see it has returned yes as it's there. Let's write a number that's not there in the list, and let's say 9, and let's run the code. So we can see that 9 was not there in our list, so it has returned no. Now moving ahead to the questions based on stack. So the first question we have here is, what is a stack? Stack is a data structure used to store a collection of objects. Individual items can be added and stored in a stack using a push operation. Objects can be retrieved using a pop operation, which removes an item from the stack. When an object is added to a stack, it is placed on the top of all previously entered elements. Stack is a recursive data structure which has a pointer to its top element. The stack is sometimes called as last in, first out list. That is, the element which is inserted first in the stack will be deleted last from the stack. So the next question we have here is, explain some applications of stack. So the first application is expression handling. It is used in infix to postfix or infix to prefix conversion. The stack can be used to convert some infix expression into its postfix equivalent or prefix equivalent. These postfix or prefix notations are used in computers to express some expressions. These expressions are not so much familiar to infix expression, but they have some great advantages also. We do not need to maintain operator ordering or parentheses. Next, it is used in postfix or prefix evaluation. After converting into prefix or postfix notations, we have to evaluate the expression to get the result. For that purpose, we dive into some way. If that way is not efficient, we come back to the previous state and go into some other path. To get back from the current state, we need to store the previous state. For this purpose, we need a stack. The next application is backtracking procedure. Backtracking is one of the algorithm designing technique. For that purpose, we dive into some way. If that way is not efficient, we come back to the previous state and go into some other path. To get back to the current state, we need to store the previous state. For that purpose, we need a stack. One of the examples of backtracking is finding the solution for n-queen problem. Another great use of stack is during the function call and return process. When we call a function from other function, that function call statement may not be the first statement. After calling the function, we also have to come back from function area to the place where we have first left our control. So we want to resume our task and not restart it. For that reason, we store the address of the program counter into the stack and then go to the function body to execute it. After completion of the execution, it pops out the address from the stack and assigns it into the program counter to resume the task again. Another great use of stack is during the function call and return process. When we call a function from other function, that function call statement may not be the first statement. After calling the function, we also have to come back from the function area to the place where we have first left our control. So we want to resume our task and not restart it. For that reason, we store the address of the program counter into the stack and then go to the function body to execute it. After completion of the execution, it pops out the address from the stack and assigns it into the program counter to resume the task again. Moving ahead to the next question, which data structure is used to perform recursion? So the answer is that the stack data structure is used in recursion due to its last in first out nature. In recursion, the same function calls itself. When the last call terminates, it returns the value to the parent caller function. Again, the parent caller function returns the value to its parent function and so on. If we look at the return nature of recursion, it also follows last in first out. That's why we use stack to maintain the hierarchy of recursive functions. So the next question we have here is, what is stack overflow and stack underflow? So a stack overflow is a runtime software bug when a program attempts to use more space than is available on the runtime stack, which typically results in program crash. While stack underflow is an error condition that occurs when the item is called from the stack, but the stack is empty. Moving on to the next question, what is the condition of stack overflow? So as we already know what stack overflow is, but the condition for stack overflow can be represented as top is equal to n-1, where n is the number of elements in the stack. So here the top is pointing to the index at n-1 position. So the next question we have here is, in how many ways we can implement stack? So there are two ways to implement stack. One is using arrays and another using linked lists. Now let's understand how do we implement stack using arrays. A stack data structure can be implemented using one-dimensional array, but stack implemented using array stores only a fixed number of data values. This implementation is very simple. Just define a one-dimensional array of specific size and insert or delete the values into the array by last in first out principle with the help of a variable called top. Initially, the top is set to -1. Whenever we want to insert a value into the stack, increment the top value by 1 and then insert. Whenever we want to delete a value from the stack, then delete the top value and decrement the top value by 1. The next way is using linked list. Instead of using arrays, we can also use linked list to implement stack. Linked list allocates the memory dynamically. However, the time complexity in both the scenarios is the same for all the operations like push, pop, and peek. The main advantage of using linked list over arrays is that it is possible to implement a stack that can shrink or grow as much as needed. Using an array will put you a restriction to the maximum capacity of the array, which can lead to stack overflow. Using linked list, each node can be dynamically allocated, so overflow is not possible. Now let's see some of the questions based on queue. So the first question is, what is queue? Queue is a data structure which is somewhat similar to stack. The difference is that queue is open at both ends. One end is used to insert the data and the other end is used to remove the data. Queue follows first in first out methodology. That is, the data item stored first can be accessed first. This is exactly how queue system works in real world. If you go to the ticket counter to buy movie tickets and you are the first one in the queue, then you will be the first one to get the ticket, right? Same is the case with queue data structure. Data inserted first will leave the queue first. Moving ahead with the next question, which operations can be performed on queue? So the operations include enqueue, dequeue, pick, is empty, and is full. So enqueue is used to add an element to the queue. Dequeue is used to remove the item from the front of the queue. Then we have peek. It gives the value of the front item without removing it. After that, we have isEmpty function. It checks if the stack is empty. And then isFull function checks if the stack is full. So the next question is list some applications of queue data structure. So the first one is that queues are widely used as waiting list for a single shared resource like printer, disk, or CPU. Apart from that, queues are used in the asynchronous transfer of data, where data is not being transferred at the same rate between two processes. For example, pipes, file I/O, or sockets. Then queue are used as buffer in most of the applications like MP3 media player or even CD player. Next application is that queues are used to maintain the playlist in media player to add and remove the songs from the playlist. And the last application is that queues are used in operating systems for handling interrupts. So the next question we are going to discuss is what is the condition to check whether a circular queue is full or not. So there are two cases in which element cannot be inserted. First, when front is exactly equal to 0 and rear is equal to max minus 1. This means that front is at the first position of the queue and rear is at the last position of the queue. And the next condition is when front is exactly equal to rear plus 1. Now moving on to the next question, explain the concept of priority queue. Priority queue is the collection of elements such that each element has been assigned a priority, that is, order in which elements are deleted or processed. An element of high priority is processed before any element of lower priority. The next question is which data structure is used for implementing LRU cache. So we have two data structures to implement LRU cache. First one is queue. So queue is implemented using doubly linked list. The maximum size of the queue will be equal to the total number of frames available. The most recently used pages will be near the rear end and the least recently used pages will be near the front end. The next data structure is hash. A hash with page number as key and the addresses of the corresponding queue node as value can be used here. Now let's see few questions based on tree data structure. So the first question is what is a tree data structure? So tree is a recursive data structure containing a set of more than one data nodes where one node is designated as the root of the tree while remaining nodes are called the children of the root. The nodes other than the root nodes are partitioned into non-empty sets where each one of them is called a subtree. So tree is a recursive data structure containing a set of one or more data nodes where one node is designated as the root of the tree while remaining nodes are called the children of the root. The nodes other than the root nodes are partitioned into non-empty sets where each one of them is called to be a subtree. Now moving ahead to the next question, what is a binary tree? A binary tree is a special type of generic tree in which each node can have at most two children. A binary tree is generally partitioned into three subsets. That is the root of the node, left subtree, and right binary subtree. A binary tree node contains the following parts. First is data, then pointer to the left child, and pointer to the right child. Now the next question we are going to discuss is explain the different types of binary tree. So the types include full binary tree, complete binary tree, skewed tree, under which we have left skewed tree and right skewed tree. So in full binary tree, every node has 0 or 2 children, while in complete binary tree, all internal nodes have 2 children. A skewed tree is a type of tree that goes in a single direction. It can be either left skewed or right skewed. In left skewed tree, node have only left child and no right child, while in right skewed tree, nodes have only right child and no left child. Moving ahead to the next question, give a basic algorithm for searching a binary search tree. So here we first check if the tree is empty. If the tree is not empty, then the target is in the tree. Then we check if the target is in the root item. If the target is not the root item, then we check if the target is smaller than the root's value. If the target is smaller than the root's value, then we search the left subtree. Else, we search the right subtree. Now moving ahead to the next question, what are the differences between B tree and B plus tree? So in B tree, the search keys cannot repeatedly be stored, while in B plus tree, redundant search keys can be present. In B tree, data can be stored in leaf nodes as well as internal nodes, while in B plus tree, data can only be stored in the leaf nodes. Next, in B tree, searching for some data is a slower process since data can be found on internal nodes as well as on the leaf nodes. While in B plus tree, searching is comparatively faster as data can only be found on the leaf nodes. In B tree, deletion of internal nodes is complicated and very time consuming, while in B plus tree, deletion will be never complicated process since element will always be deleted from the leaf node. The last difference is that B tree leaf nodes cannot be linked together, while in B plus tree, leaf nodes are linked together to make search operation more efficient. So the next question we have here is, what is an AVL tree? An AVL tree is a height balancing binary search tree in which differences of heights of the left and right subtrees of any node is less than or equal to 1. This controls the height of the binary search tree by not letting it get skewed. This is used when working with a large dataset with continual pruning through insertion and deletion of data. So the next question we are going to discuss is, what are the different operations applied on AVL tree? So the operations include left-left rotation, left-right rotation, right-right rotation, and right-left rotation. Let's consider P is the node with violating balance factor. So in left-left rotation, we right rotate the node P, while left-right rotation is a combination of left rotation followed by right rotation. Then we have right-right rotation. Here we left rotate the node P. And lastly, we have right-left rotation, which is a combination of right rotation followed by left rotation. Moving ahead, let's see the next question. So what is the degree of a node? The degree of a node is the number of children, or you can say the number of subtrees of a node. Here in the example, you can see the node 1 has 2 children, or you can say 2 subtrees. Hence, the degree of that node is 2. Similarly, we have node 5, but here it has 3 children. So the degree of node 5 will be 3. So the next question is, what is the degree of a tree? So degree of a tree is the maximum degree of any of its node. For example, here you can see the node 1's degree is 2, node 2's degree is again 2. Node 3's degree is 0 as it does not have any children, but node 5's degree is 3, which is highest among all the nodes. Hence, the degree of the tree will be 3. Moving ahead to the next question, explain spanning tree. A spanning tree is a subset of a graph which has all the vertices covered with minimum possible number of edges. Hence, a spanning tree does not have cycles and it cannot be disconnected. By this definition, we can draw a conclusion that every connected and undirected graph has at least one spanning tree. A disconnected graph does not have any spanning tree, as it cannot be spanned to all its vertices. Now moving to the next question, what is a minimum spanning tree? In a weighted graph, a minimum spanning tree is a tree that has minimum weight than all other spanning trees of the same graph. In real-world situation, this weight can be measured as distance, congestion, traffic load, or any arbitrary value denoted to the edges. Now let's see some questions based on graph data structure. So the first question is define the graph data structure. So a graph is a non-linear data structure consisting of nodes and edges. The nodes are sometimes also referred to as vertices, and the edges are lines or arcs that connect any two nodes in the graph. Moving on to the next question, differentiate among cycle, path, and circuit. So a cycle can be defined as a closed path where initial vertex is identical to the end vertex. Any vertex in the path cannot be visited twice. While a path is a sequence of adjacent vertices connected by the edges with no restrictions. While cycle can be defined as a closed path where initial vertex is identical to the end vertex, and any vertex in the path cannot be visited twice. The third one is circuit. A circuit can be defined as a closed path where initial vertex is identical to the end vertex, and any vertex may be repeated. So the next question we'll be discussing is how does depth first traversal work? In depth first search, we traverse the graph in a depthward motion and use a stack to remember to get to the next vertex to start the search when a dead end occurs in any iteration. Now the next question is how does breadth first traversal work? So in breadth first traversal, we traverse a graph in a breadthward motion and use a queue to remember to get to the next vertex to start a search when a dead end occurs in any iteration. Now let's see some important questions based on algorithms. So the first question here is explain Dijkstra algorithm. So Dijkstra's algorithm allows you to calculate the shortest path between one node of your choice and every other node in a graph. Let's understand this better by knowing how the algorithm works. So first we mark all the nodes of the graph as unvisited. Then we mark the selected initial node with a current distance of 0 and rest as infinity. After that, set the initial node as the current node. For the current node, consider all of its unvisited neighbors and calculate their distances by adding the current distance of current node to the weight of the edge connecting neighbor nodes and current node. Now compare the newly calculated distance to the current distance assigned to the neighboring node and set it as the new current distance of neighboring node. When done considering all of the unvisited neighbors of the current node, mark the current node as visited. If the destination node has been marked visited, then stop. The algorithm has then finished. Otherwise, select the unvisited node that is marked with the smallest distance, set it as the new current node, and repeat the whole process. Now moving ahead to the next question, what are the different approaches to develop algorithms? So there are mainly three approaches. First one is greedy approach, then you have divide and conquer approach, and the third one is dynamic programming. Now the next question is explain greedy approach. An algorithm that follows greedy approach builds a solution in a step-by-step manner. It is mostly used in optimization problems. It makes optimal choice at each step to solve the entire problem. Its examples include Dijkstra's algorithm and Prime's algorithm. The next question is explain divide and conquer approach. So an algorithm that follows divide and conquer approach works in two steps, divide and combine, At first, we divide the problem into subparts, solve them individually, and then combine the result of all the subparts to get a collective solution. Its examples include binary search and merge sort. Moving ahead, the next question is explain dynamic programming. Dynamic programming is used to find the most optimized solution by eliminating the standard recursive call. Dynamic programming approach is similar to divide and conquer in breaking down the problem into smaller and yet smaller possible subproblems. But unlike divide and conquer, these subproblems are not solved independently. Rather, results of these subproblems are remembered and used for similar or overlapping subproblems. Dynamic programming is used where we have problems which can be divided into smaller subproblems so that their results can be reused. Mostly, these algorithms are used for optimization. Before solving the in-hand subproblem, dynamic algorithm will try to examine the results of the previously solved subproblems. The solutions of subproblems are combined in order to achieve the best solution. The examples include finding Fibonacci series and knapsack problem. Moving on, the next question is what is Huffman's algorithm? Huffman coding is a lossless data compression algorithm. In this algorithm, a variable length code is assigned to input different characters. The code length is related to how frequently a character is used. Most frequent characters have the smallest codes and longer codes for least frequent characters. There are mainly two parts. First one is to create a Huffman tree and the other one is to traverse the tree to find codes. For example, consider a string as displayed here. The frequency of character A is larger than B and the character C has the least frequency. So the length of code for C is smaller than B and the code for B will be smaller than A. Complexity for assigning the code for each character according to their frequency is O of n log n. Moving ahead to the next question. What is Fibonacci series? Fibonacci series is a search algorithm that applies to a sorted array. It makes use of divide and conquer approach that can significantly reduce the time needed in order to reach the target element. In Fibonacci series, next number is the sum of previous two numbers. For example, the series as shown here on the screen. The first two numbers of Fibonacci series are 0 and 1. Now the next question is what is an interpolation search technique? Interpolation search is an improved variant of binary search. This search algorithm works on probing positions of required values. For this algorithm to work properly, the data collection should be in a sorted form and equally distributed. Binary search has a huge advantage of time complexity over linear search. Linear search has worst case complexity of O of n, whereas binary search has O of log n. There are cases where the location of target data may be known in advance. For example, in case of a telephone directory, if we want to search for a telephone number of Morse, here linear search and every binary search will seem slow as we can directly jump to the memory space where the names starts from M are sorted. But how does an interpolation search techniques algorithm work? So here we start searching for the data from the middle of the list. If it is a match, then we return the index of the item and exit. If it is not a match, probe position. Divide the list using probing formula and find the new middle. If data is greater than middle, search in higher sublist. If data is smaller than the middle, search in the lower sublist. Repeat until the match is found. Moving ahead, the next question is what is merge sort? Merge sort is a divide and conquer algorithm for sorting the data. It works by merging and sorting adjacent data to create bigger sorted lists, which can then be merged recursively to form even bigger sorted lists until you have one single sorted list. Now the next question is how does selection sort work? So selection sort works by repeatedly picking the smallest number in ascending order from the list and placing it at the beginning. This process is repeated moving towards the end of the list or sorted subarray. How it works is we scan all the elements and find the smallest one. We then switch over the position of that element with the first element. Then we repeat the selection sort on the remaining n-1 items. We always iterate forward and swap with the smallest element. The best case and worst case time complexity for selection sort is O of n square, and the worst case space complexity is O of 1. Moving ahead, the next question is explain the working of quicksort. Quicksort is a highly efficient sorting algorithm and is based on partitioning array of data into smaller arrays. A large array is partitioned into two arrays, one of which holds values smaller than a specified value, say pivot, based on which partition is made, and another array holds values greater than the pivot value. Now, how does it exactly works? A pivot element is chosen from the array. You can choose any element from the array as pivot element. The elements smaller than the pivot element are put in the left, and the elements greater than the pivot element are put on the right. Then the pivot elements are again chosen from the left and right subparts separately. Within these subparts, the pivot elements are placed on their right position. Further, the subparts are again divided into smaller subparts until each subpart is formed of a single element. At this point, the array is already sorted. The complexity of quicksort is O of n log n. The next question is what is the worst time complexity of quicksort? So the worst time complexity of quicksort is O of n square. This happens when array is already sorted in the same order, or if array is already sorted in the reverse order, or this happens even if all the elements are the exact same. Now moving ahead to the next question, what is radix sort? Radix sort is a sorting technique that sorts the elements by first grouping the individual digits of the same place value, then sorting the elements according to their increasing or decreasing order. Now suppose we have an array of 8 elements. First we will sort elements based on the value of its units place. Then we will sort the elements based on the value on its tens place. This process goes on until the last significant place. You can understand this by the example displayed here. We have numbers like 121, 432, 564, 23, 1, 45 and 788. As you can see in the diagram, the sorting first starts from the units place, then the tens place, and moving further to the hundreds place. Moving on, the next question is what are the disadvantages of radix sort? Since radix sort depends on digits or letters, radix sort is much less flexible than other sorts. Hence, for every different type of data, it needs to be rewritten. The further disadvantage is that the constant for radix sort is greater as compared to other sorting algorithms. And lastly, radix sort takes up much more space than quicksort, which is in-place sorting. Now the last question in the algorithms section is which sorting algorithm is considered the fastest? There are many types of sorting algorithms like quicksort, bubble sort, balloon sort, radix sort, merge sort, and many more. But not one can be considered as the fastest because each algorithm is designed for a particular data structure and data set. It would depend on the data set that you would want to sort. Finally, let's see an interesting mathematical puzzle that makes use of data structure and is also commonly asked during interviews. So the puzzle that we are going to discuss here is Tower of Hanoi. Tower of Hanoi is a mathematical puzzle where we have 3 rods and n disks. The objective of the puzzle is to move the entire stack to another rod obeying the following rules. The first one is that only one disk can be moved at a time. The second rule is that each move consists of taking the upper disk from one of the stack and placing it on top of another stack. That is, a disk can only be moved if it is the uppermost disk on a stack. Finally, the third rule is that no other disk can be placed on top of a smaller disk. Now let's see the approach that can be followed. Now in this case, the uppermost disk on the rod will be referred to as first disk of the rod. So to solve a problem with 3 disks and 3 rods, we can follow the following approach. We first move the first disk from A to C, then move the first disk from A to B. After that, we move the first disk from C to B. Moving ahead, move the first disk from A to C. After that, we move it from B to A, B to C, and then A to C. Now, it can be a little confusing, but you can refer to the diagram as shown over here. It follows a similar approach. But how can we implement this puzzle using data structures and everything that we have discussed so far? Let's understand that now. So here's a Java code for Tower of Hanoi. So initially what we have done is we have created a class. In that we have this function Tower of Hanoi. Here n represents the number of disks. From rod represents the rod from which we need to move the disks. After that we have to rod, which is the destination rod where we need to place all these disks. And aux rod can be considered as the secondary rod. Now here in the if condition we are checking if the disk number is equal to 1. So if it is equal to 1, we just need to move the disk from the from rod to the to rod, which is from the starting rod to the destination rod. Okay. After that, if this is not the case, like the number of disk is not equal to 1, then what happens is that it enters this loop. So in this loop what is happening is we are calling the function Tower of Hanoi for n minus 1, that is number of disks minus 1, and then we are again recalling the function of Tower of Hanoi for n minus 1 disk for moving it from the initial to the final destination. So here we are following a recursive way of calling the functions. So this is the main class from where the execution actually happens. So we are calling here the Tower of Hanoi function. After that we are passing n as number of disk. A is the initial rod, which is the from rod. C is the final rod, as you can see, or the to rod. And then we have the aux rod or the secondary rod as B. Now, if you run the function, you can see that the result that we have got is exactly the same as we were discussing it before. Since we have considered 3 disks, this is a solution for moving 3 disks from the initial destination to the final destination. You can see that the solution that we got from the code resembles to the solution as given over here. With this, we come to the end of this session. If you have any queries, please feel free to mention it in the comment section below.